introduction to chapter 6, which the focus of chapter 6 is on quadrilaterals, but we're going to start by talking about polygons in general. We're going to take the stuff we did with triangles and expand on it a little bit. So before we get started with all that fun stuff, we need a quick review. Ben, what's a polygon?
It is a four-sided. Oh, never mind.
No.
It is a shape that has all closed sides.
Okay.
It doesn't bend or cross.
Okay. Is that how we defined it way back when?
No.
What is it? Somebody look it up. How do we define it? Chapter, I don't know, 3 maybe? Chapter 4? Section 4.1, section 5.1, something like that. You got it, Megan? Go.
Polygon has no curved surfaces and closed sides and only intersects at the endpoint.
Beautiful.
Say it again. No curved surfaces.
No curved sides. Let's change surfaces to sides because we're in 2 dimensions still. Okay. No curved sides.
Closed shape.
It's closed,
And only intersects at endpoints.
and the sides only intersect at the end.
What section?
So if you look at the ones over there on the right that are not polygons, they violate the 3 things that it can't do. It has to be closed. That one's open. The sides intersect at points other than their endpoints. And the bottom one has a curved side. Sides have to be segments. Okay, you knew that already. And then you know this already also, right? That's a triangle. Let's see, Morgan, can you make it through all of those? What's the green thing? Yep. And how about the army green or puke green below it? Okay. And then now we're jumping over to the white thing in the lower left. Outstanding. Where do we go to next? The gray thing, I believe. Okay. For bonus point, what's the other name? Shh. Heptagon is correct, but can you get the bonus question? Subash, what is it?
Septagon.
Septagon, good. Okay, red thing, Morgan? Stop sign. And then the yellow? And last but not least, the purple thing is a? Oh. No, I'm sorry, that's incorrect. Dodeca is 2 plus 10. So that would just be a decagon, correct? 11 sides, Morgan? I don't have one, but what would 11 sides be called? Say again? Say again? Undecagon, and we already covered 12, which was dodecagon. Molly, what's a 13-sided polygon called? A terceragon, right, the most feared of all dinosaurs. Don't listen to him.
Okay. Kind of learned some time.
Right, we could go that route. We could call it a tridecagon and then go quaddecagon. But when we started talking about polygons, how do we handle anything bigger than 12? Say again? No, just a 13 gon. Yeah, the number of sides followed by a dash and a gon. So a 37-sided polygon is a 37 gon. Awesome. So, what about the polygon sum theorem? We know already that the sum of the angles in a triangle is equal to Thank you. Let's suppose I want to find the sum of the angles in this, in that thing, quadrilateral. Why 360? Prove it.
90 plus 90 plus 90.
Those aren't 90s.
Yeah, they can be.
They can be, but they don't have to be. Michelle.
If you create a line in between 2 vertices, it will create 2 triangles.
Like that?
Yeah.
Just one?
You can do
No, I don't want to. I just want to do one. Okay? So she took that quadrilateral and split it into two triangles, triangle I and triangle II. What's the sum of the angles in triangle I?
180.
Triangle 2? 180 plus 180? 360. Okay, how about a pentagon? Whoop. What's the sum of the angles in a pentagon? You're going to need your calculators, by the way, if you want to get those out. Nicole?
Isn't it like 540?
Why?
You draw, if you do like, say, if you draw like one line and two vertices, you'll have a triangle and a quadrilateral. So 360 plus 180 is 540.
Let's take an easier approach. Let's do this. 3 triangles. Right?
Yeah.
Triangle I, and III. Each one of those is 180. Add them all up. 3 times 180 is 540. Okay. Let's go to a hexagon then. 1, 2, 3, 4, 5, 6. Using Michelle's technique again, from one vertex we make a bunch of triangles. How many triangles will I get out of a hexagon?
4.
I, and IV. I. 4 times 180 is? Good. That'll help you on the next quiz.
720.
720. Good. Suppose I have 13 sides. I'm dealing with a 13-gon. How many triangles will I get? 11. Suppose I'm dealing with an n-gon. How many triangles? N minus 2. Therefore, if I have an n-gon and I don't know the number of sides, how do I find the sum of all the angles?
Subtract by, I mean 2.
I'm sorry?
Subtracted by 2.
And then?
Multiply that by 80, or 180.
Well done. Multiply that by 180. Okay, that's called the polygon sum theorem. So if I get rid of this mess, go back to here and click. And there's all the triangles that Michelle talked about. And that leads us to that formula. N minus 2 times 180, and that n minus 2 needs to be in parentheses. Or you can write it as 180 times n minus 360, but I like it that way better. Notice the notation here, capital S. Capital S stands for the sum of the measures of the angles in a polygon. It doesn't tell you anything about the individual angles. We have no idea how much each individual angle is. We just know that if I take all the angles and add them up, you would get 180. It's the exact same thing that we did with triangles. You know the sum of the angles in a triangle is 180. It doesn't tell you anything about the individual angles. Any problems with that? Pretty straightforward. Got a little corollary. What's a corollary? I know we've used the word before. Paul, ask Siri what a corollary is.
What's a corollary?
That's it? Just, that's no, not a correlate. It's a corollary. C-O-R-O. Yeah, there you go. Kind of defeats the purpose when you have to type it in, though.
Yeah. Might as well just Google it.
Series of know-how. What Siri do you have? Do you have male or female? Female? American? British? New Zealander?
I have Australia.
Australian, very nice. You sure it's not New Zealand? Okay, good. So what's a corollary, Paul?
A corollary is a statement that follows readily from a previous statement in mathematics. Corollary typically follows a theorem. The use of the term corollary rather than propositional.
Keep going.
Rather than proposition or theorem is intrinsically subjective.
Were done?
No.
Keep going.
Keep going, Paul.
Yeah, come on, Paul. You going back to that now?
What's a corollary?
She's gonna look up like cow or something.
What's a
She look up,
corollary?
yeah.
You won't start talking.
No, because you laughed and you thought you said yeah.
What's a crawler?
Alright.
You have to enunciate.
Did we get enough out of his previous definition?
No.
What is a corollary?
Oh, got it right, nice. Okay.
Alright. Is intrinsically subjective. Proposition B is a corollary of proposition A. If B can be readily if B can be readily deduced from A.
Great, let's go back to the first, blah, 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 blah. Go back to the first sentence of your definition. Oh, what is it?
It follows the theorem.
Yeah, it follows a theorem. It's like a sub-theorem. It's not big enough to get its own theorem, but it is important enough to be something that we want to write down. In red up there, I have the word regular. What is a regular polygon? Becca, do you remember?
It's a polygon that has, the sides are all the same length and the angles are all the same.
Perfect. So this corollary applies only to regular polygons, not to any old, plain old polygon. It's got to be regular. If it's a regular polygon, we can then find the measure of one angle. So let's suppose we have a regular quadrilateral, which you'll learn later is called a square, and we want to know the measure of one of the angles. We could do 4 minus 2 times 180 divided by 4. In other words, the top, the numerator, gives us the sum of all the angles. The denominator divides it out to find out the measure of each of those individual angles. Make sense? Some of you are going to use this formula on non-regular polygons. Again, it only works for regular polygons. You have to know that all the sides are equal and all the angles are equal. How are we doing so far? Good, good, good. Find the sum of the interior angles in a nonagon. And notice that's a nonagon, not an n-gon. Question? Answer. Hold on. Give everybody a chance. Paul asked Siri.
What?
What's the sum of the angles, interior angles in a nonagon? See what she comes up with. See if she's any good.
Say it in your regular voice. See what she actually hears.
Do it in a funny accent.
No, do it in like some Australian accent.
Alright.
Alright, just go ahead.
Challenge accepted.
Yeah.
You go for it.
Alright, so what's the question?
Bat. But change it to a question. What is the sum of the interior angles of a nonagon?
Did you get stage fright?
You
Get in trouble with the whole
What is
speech.
the sum of the interior angles of a nonagon?
You got nonagon pretty well.
Does it work?
And she just responds, are you trying to do an accent?
It works.
What'd she say?
1,206.
That's what I
Is that what you guys got?
Yeah.
Boom, math.
Really?
She's smart.
She literally just Googled it and it came off for like.
She always cheats. She always uses the internet. She doesn't know anything.
Yeah, she's
Yeah.
dumb.
He's like, here's
She's
your
programmed.
Unless you ask her what 0 divided by 0 is.
That's
Oh yeah.
Anybody have a problem with 1260?
That's hilarious.
What's n in problem number 1? 9. 9 minus 2 is 7 times 180 gives us that 1260. Okay. Notice we don't know how big any of the individual angles are, except they have to be less than 180 but greater than 0. We just know that when you add them all up, you get that. Okay, 1260. Yeah, good. All right, find the measure of all 4 angles. I think we've talked about this while you're working. I'll reiterate. Notice how we name figures now. Okay, just like a triangle, the order is important. Here we name it by picking any point and going around the figure either clockwise or counterclockwise. There's a lot of different names for that quadrilateral. I have RSTU, you could have done RUTS, you could have done TURS. What you can't do is go RSUT. You have to go in order around the figure.
Here's my calculator.
Oh my.
I was wondering.
Clear. Whoa.
No, like clear the history.
Why are you doing something out there you don't want to?
Yeah, really?
Calculator.
Were you on some bad websites on your calculator?
Honestly, Mary.
I want my mom to know I was doing calculus.
Michael, what you doing there on your calculator, huh?
What?
Oh, it's great.
Come on.
What is it?
Ashley, what'd you get for X?
11.
How do we feel about that? How'd you get 11, Ashley?
I added all 4 of the angles and then set it equal to 360.
Beautiful. By now you should know that some of the angles in a quadrilateral are 360. That's something you're just going to be able to memorize. The other ones you may have to actually calculate. Add them up, set them equal to 360, solve for X, and therefore the angle measures are?
Angle T and R are 55, and then angle S and U are 125.
Which makes sense because there should be, yeah, good. Well done. Any problems? Awesome. Yeah, there's all the math in case you wanted to see it, but you're all fairly bright, so it shouldn't have been a big deal. This one, however, ramps it up a little bit. I don't know for everyone. You might want to draw a sketch. You don't have to. This is America. How many sides on an octagon? 8. How many angles in an octagon? 8. Good. As we move forward and continue to calculate the sum of the angles in a polygon, you don't have to do the triangle thing anymore. Just use the formula. What is that? Where's your calculator? I forgot it. Oh boy. Famous last words. Grace, what do you got?
The 6 angles that are congruent are 130, and then the other 2 are 150.
Does everybody back her up on those? Oh, got a couple thumbs up. Tell us how you did it, Grace.
I found the sum, which would be 1080.
Good. 8 minus 2 times 180 gives us the sum of the angles in any octagon being 1080. Back to you, Grace.
And then I added all the angles together and the 20 more than the measure of the 6 angles.
So what did you call those 6 angles?
X.
X, good.
And then the other ones would be 20 plus X.
Good.
I added those all together to equal 1080 and then got X equals 130. And then I added 20 to get 150.
Perfect. Find X in that picture. By the way, those should all not have the same tick mark, because that would be silly. So we just won a prize or something? You heard that, right? Jack, what do you got?
110 degrees.
110. Anybody else?
Yeah.
Tell us how, Jack.
I added up all the sides that I knew what they were, so I got 610, and I subtracted that from 720.
Where'd 720 come from?
It's the sum of all the interior angles.
Of a
Hexagon.
hexagon. Well done. 6 minus 2 times 180 gives us the sum of 720. Added all that other stuff, subtract. We get 110. Any problems? Exterior angle sum theorem. So we did exterior angle theorem for triangles. Now we do it for polygons. So first of all, we need to define an exterior angle for a polygon. But we don't really need to because it's the same definition we had for a triangle, which was? A little more than that. Not necessarily. What's the definition of an exterior angle? Thanks, Einstein.
It equals the angle, I mean, negative, the two.
Now, you're telling me what it equals. I want to know what is it.
Nice job.
Not supplementary. It's got to be more than that. Yes, it's an angle that forms a linear pair with an interior angle in a polygon. Can't just be supplementary because it could be anywhere. It's got to be a linear pair. Got to be right next to it. Okay, so we just did that. Okay, good. Step ahead of the game. What happens when you add up all the exterior angles in a quadrilateral? Well, draw a quadrilateral. Put an exterior angle at each vertex. And add them up. What do you get? Anybody? Go ahead.
Some of the interior angles.
Which is? Give me a number.
360.
360. Okay, so if you were clever about it, you chose a nice, pretty quadrilateral that's got 90 degree angles. Exterior angles would look something like this, one per vertex. That's 90, that's 90, that's 90, that's 90, and therefore 4 times 90 is 360. Hot diggity. What about a triangle? Let's go back to a triangle because we never really did talk about the sum of that. What would be a smart triangle to use?
Equilateral.
Equilateral. 60, 60, and 60. How big would the exterior angle of a 60-degree angle be? 120. What's the sum? 360. Let's suppose we go to a pentagon. What do you think the sum would be? 360. Octagon? 360. So you guys are good at pattern recognition. This will trip up many of you because you're not comfortable with a value like this that stays the same for all polygons. Regardless of how many sides the polygon has, the sum of all the exterior angles is equal to 360. And you can think about as the number of sides of the polygon grows, the size of the exterior angles shrink. You have more of them, but they're smaller. So they always stay the same value of 360 degrees. Okay, we good? So, find the measure of one exterior angle in a regular decagon. It should be done by now. What's the answer? 36. What's the sum? 360. How many of them are there? 10. 36, that's 10, not 8. Octagon, not decagon. 360 divided by 10 is 36. Just for giggles, find the measurement of one angle, one interior angle of the decagon, please. 144. So now knowing the exterior angle leads us to two different ways to solve that problem. Up until we talked about the exterior angle, you would have used the corollary, n minus 2 times 180 divided by n, which would be 8 times 180 divided by 10, and that would have given you 144. But notice now that we know the exterior angle is 36, if this angle is 36, and we know that these two angles are supplementary because they're a linear pair, 180 minus 36 equals 144. So you have two options now to solve that type of problem. You can use either one. Okay. Find x and the measure of ABC. This is our last example. That's because it says last example at the top. Just so nobody goes down the dark path. What kind of polygon is that?
Pentagon.
It is a pentagon. You're solid. Yep. I had a brain fart there for a second, sorry. I'm sorry? Vanessa, never let strangers in the room, unless it's the principal. Sit in the comfy chair if you'd like. Hey everybody, it's Principal Dowling.
Hi, Principal
Dowling. Oh, that's scary. That's like stuff.
That's Village of the Damned right here. All right, Emily, what do you got for X?
I didn't get it yet.
Oh, come on. What do you got? What are you trying? Let's do it that way.
Well, I think that the sum of the thing is 540. Am I correct?
The sum of the interior angles is in fact 540. However, what kind of angles are we dealing with?
Exterior angles.
And what do you know about the sum of the exterior angles?
They equal 360.
Okay. Shall we wait for you?
You can go ahead.
Oh, thank you. Rebecca, what do you got?
I got x equals 30.
X equals 30 peoples?
Yeah.
How? Wait, hold on. You got 36?
Yeah.
All right, listen to what she says.
Okay, so since I know that all the exterior angles add up to 360, I added 2x plus 2x plus x plus 3x plus 4x equals 360. And that adds up to 12x equals 360, so I divide by 12. And that's how I got x equals 30.
Okay, good. Now, what did you get for ABC?
So since I knew that x equals 30, I multiplied it by 4 to find the exterior angle for BAC.
Perfect.
And then I subtracted that from 180.
And got what?
60.
Good. Problems? Okay. Emily, you good on that?
Yeah, I see.
Yeah. You were right. The interior angles would equal 540, but we're dealing only with the exterior angles. And again, remember, that's not a regular pentagon, so you can't find the measure of the individual interior angles by doing the corollary. You have to find some other sneaky way to do it, which is what Rebecca used to find the measure of angle ABC. And now that we know that what X is, we could find all those interior angle measures to verify that they're 540. We're not going to, but we could. Okay. A couple common mistakes that happen when you get into this chapter. Number one, people don't show their work. If you plug into a formula, you need to show the blank formula first. Don't make numbers magically appear out of nowhere. So if you're calculating the sum of the interior angles in a nonagon, for instance, like we did before, start with the blank formula, n minus 2 times 180, plug in for n, solve for an answer. The exceptions would be a triangle and a quadrilateral. We can accept the fact that you know that the sum of the angles in a triangle is 180, the sum of the angles in a quadrilateral is 360. Everything else you need to show a formula. If you calculate a problem like this, start with a blank equation. Okay? Again, my point being, don't make numbers appear out of nowhere. I want to see your work. Otherwise, all I can do is grade the answer, and that's just going to be right or wrong. Okay? We're going to take this idea of big polygons and narrow it down to just quadrilaterals for the rest of the chapter. So we're going to talk about all these different quadrilaterals that you probably already know what they are, but we're going to have to write definitions for them and be able to work with them from this point on. The difficult part is going to be distinguishing what makes each quadrilateral each quadrilateral. Okay, what makes a square? What makes a rhombus? What makes a parallelogram a parallelogram?
It's rhombus. I can deal with isosceles. I cannot deal with rhombus.
Rhombus.
Stop.
R-H-O-M-B-U-S.
It's rhombus.
It's a silent H.
No, it's not. Why would they put an H in a word that's silent?
Because
For the same reason they put an H.
What? They pronounce everything, right?
No, they don't pronounce H's.
They don't pronounce H's? But a rhombus was not discovered by a Spaniard. It was discovered by a Roman, or a Greek, actually. The Greeks don't put silent H's in words.
they have an H.
I don't know if the Greeks have an H in their alphabet. Yeah, they have an eta, which looks like an H. Alpha, beta, gamma, delta, epsilon, zeta, eta, yeah, it looks like an H.
Siri, how do you say rhombus?
Wait, think about the question you're asking.
That's what you put in Google Translate.
Alright, yeah.
Paul, that would be like me saying, how do you spell dog? Paul, how do you spell that word?
I don't know.
Okay, good. Did you just respond, you're a chucklehead? Rhombus. So we'll talk about Quadrilateral is a general term. We'll talk about parallelograms, kites, trapezoids, rhombus, and squares and rectangles.
What is a kite?
Well, we'll get there. We don't want to jump the gun. All right, we good? Now, you know the schedule for the week. Like I said, I'll post the final review material later this week if you want to take a look at it over break. Otherwise, you've got day 1 from chapter 6. Does anybody know right now that they're not going to be here the rest of the week? Awesome. Then I'll assume that everybody's going to be here for all the fun and excitement coming up. Okay? Beautiful.
When are we gonna get our test back?
As soon as I get them done. I did not grade them all because my son came back from London and I would rather spend time with him because I haven't seen him for 3 months than grade